Project 3.3, AVR Assembly, Traffic Light by Atticus Stiplady. The purpose of this project is to create a functioning traffic light by developing a standalone AVR assembly language program, exploring what assembly language is and how it functions. This project entirely functions based off of the code provided. The PCB for the traffic light is quite simple, as it is just three LEDs that share one common ground through a resistor. Furthermore, a 3D design case encloses the light, and a mount that is yet to be printed is what holds it up. The basics of this project has to deal with something called assembly level code, a different language of code compared to high register found within the previous projects. An assembly language is a type of low-level programming that communicates directly to the computer's hardware. Within high-level languages, it is common to find various syntax that are pieced together, English words or sentences. While providing clarity when coding, this causes the computer to decrypt every version of syntax and then utilize that now converted code, taking up and lengthening processing time and not directly communicating with the hardware. A workaround to this issue is that rather than translating high-level commands into machine assembly language can be used, the purpose of which is to automatically translate between these high-level and low-level languages. The code begins by declaring the library needed to declare the ports in the next few lines, and the next 4 lines act similar to that of the hashtag-defined codes, defining each port using a new syntax, that being the .equ label. Following that, the global.main command is called. Global is used as the main directive, telling the assembler that the symbol preceding it should be accessible from other files or modules. In Arduino programming, the setup and loop functions define the program structure and are therefore required for our code to function properly. With an assembly level code, there is a way to bypass these two commands, and that is by implementing something referred to as the main function. That overall has the same effect, however, it condenses the code further, making it so that the loop functions need to be set up manually. Main is called as a label, acting as a marker placed within the code to jump to at any point. Following that, the outputs are declared by calling rcall, which jumps to a function declared and recalls it back to that line upon completion. The code then loads register 16 and 17 with the values placed in the variables defined above. After that, a next label is declared and performs a branch command. Since the value within register 16 is bit shifted right, every time the overflow of what is within the register is equal to 1, something called a C flag is turned on. The branching statement checks the C flag, and if there is a 1 inside of it, it will jump to the turn on the red LED command. If not, it will turn on the green LED. The code then will repeat this section 7 times as R17 decreases by 1 every time the check command is used. After R17 is equal to 0, the yellow light turns on, waits for a second, then resets R17, therefore turning on the red LED once again. The delay 1 second command works by performing a while function cycling 16 million clock cycles, equivalent to 1 real second. Moreover, the ratio between the red LED, yellow LED, and green LED is 4 to 1 to 3, which is similar to the ratio found within regular traffic lights. Thank you for taking the time to listen to my video on the AT stoplight.